Okay, now we move to solving problems. After discussing all the concept in the chapter, now we move to solving problems. Now the first problem, of course, is saying the following is Omar's PPF for two goods, namely cheese and milk. And this is the PPF, which is a concave downward PPF for Omar. Now, as you can see, of course, we have milk in liter along the vertical axis, and cheese is along the horizontal axis. Now, we have a bunch of questions here regarding this problem. The first question, is it possible for Omar to produce 9 kilograms of cheese and 9 liters of milk? Explain. This is 9 kilograms of cheese, and this is, of course, 9 liters of milk. So it is point D here. Now, question 2 is what levels of production of milk and cheese are most efficient for Omar? Explain. What are the combinations of milk and cheese that are most efficient for Omar? Now, 3, calculate the opportunity cost of production of cheese in terms of milk for Omar. 4, calculate the opportunity cost of production of milk in terms of cheese, for Omar. 5, what would you say about the opportunity cost in this case of PPF? Of course. 6, is it possible for Omar to produce 10 kilograms of cheese and 20 liters? 10 kilograms of cheese and 20 liters. That is at point C. Explain how could Omar attain level C, which is beyond the opportunity cost of production. Graph his new PPF. Let's start with the first question. Is it possible for Omar to produce 9 kilograms of cheese and 9 liters of milk? This is 9 kilograms of cheese, and this is 9 liters. It's at point D. As you can see, point D is inside the PPF, or inside the attainable region. The ones we discussed during the, discussing, the concepts in the lesson. So yes, it is possible. Yes, indeed, it is possible for Omar to produce 9 kilograms of cheese and 9 liters of milk, because this combination is located inside the attainable region. And so, the combinations that are within the attainable regions are, easily produced, okay, can be produced. Yes, indeed, which is discussed over here. Now, 2, what levels of production of milk and cheese are most efficient for Omar? So when we see or hear or read the concept of efficient, we're talking about the combinations that are along the PPF. All the combinations along the PPF are efficient. So we look at the PPF. This is the PPF. What combinations are located along the PPF? We see A and B. So we say A and B are most efficient for Omar. A and B are most efficient for Omar because they are located along the PPF. Okay? Great. So when the question is talking about efficient combinations, then all you have to do, go to the combinations that are along the PPF. And these are the ones that are most efficient. Now we'll look at 3. 3 says calculate the opportunity cost of production of cheese in terms of milk. Okay, of cheese in terms of milk. So moving from A to B, as Omar moves from A to B, you remember at A, he produces 13 liters of milk and 9 kilograms of cheese. At B, he produces 9 liters of milk and 10 kilograms of cheese. So what is the opportunity cost, of course, as he moves from A to B? As he moves from A to B, the amount of cheese increases at the expense of milk. So here, as you can see, as he moves from A to B, the amount of cheese increases from 9 to 10. That is, the opportunity cost of 1 kilogram of cheese is what? The amount of milk decreases from 13 to 9. So we say that the opportunity cost of 1 kilogram of cheese is 4 liters of milk. Is 4 liters of milk. Okay? Opportunity cost of 1 cheese equal 4 liters of milk. This is the opportunity cost of cheese. Voila. Is that clear? Now, what would you say about the opportunity cost in terms, in this case, now, calculate the opportunity cost of production of milk in terms of cheese. If the opportunity cost of cheese in terms of milk is that one cheese is 4 milk. So what is the opportunity cost of milk in terms of cheese? All you have to do, just divide this equation by 4. So we get the opportunity cost of cheese is equal 1/4 the opportunity cost of milk in terms of cheese is equal 1/4 cheese. The opportunity cost of of course, milk, opportunity cost of 1 milk equal 1/4 cheese. Okay? Opportunity cost of 1 milk equal 1/4 cheese. If the opportunity cost of 1 cheese equal 4 milk, then the opportunity cost of 1 milk, all you have to divide by 4. Divide by 4 both sides, so you get opportunity cost of 1 milk equal 1/4 cheese. Okay, great. Now we'll go to 5. What would you say about the opportunity cost in this case of PBF? Of course, the shape of the PBF tells you that we have increasing opportunity cost because the shape is what? Is concave downward or bowed outward. So whenever the shape of the PBF is concave downward, then we are talking about, increasing opportunity cost. Increasing opportunity cost. Now, what about 6? Is it possible for Omar to produce 10 kilogram of cheese and 20 liter? This is 10 kilogram of cheese, and this is 20 liter of milk. C. As you can see, C is beyond the PBF. So it's not possible. Because, remember, we divided the PBF into 2 regions. One is attainable, where the company or the economy or the individual can or is able to produce and consume, and the other region which is unattainable, where he can't produce. So combination C is beyond, above the PBF. So it is what? It's in the unattainable region. That's why we say that it's not possible for Omar to produce there. Now the question says, explain how could Omar attain level C of production? We have already talked about this. We said through economic growth. Once Omar, is able to have, economic growth, that is an increase in the amount of resources or the attaining of an advanced level of technology, then he is able to, produce at sea. Because once he has economic growth, then what will happen to the PBF? It will shift outward, to sea. Okay? So yes, we say, how could Omar attain level C of production? He could attain this level C through, economic growth. When he has economic growth, okay, or when he enjoys economic growth, then the PBF will shift outward, to C, as you see over here. Okay, now he said graph his new PBF. Of course, this is point C now. Now, once economic growth exists, then the PBF will shift outward to C, and therefore this is his new PBF. And this is here is all BBF. So with the new BBF, as you can see, he is able to produce C. Because with the new BBF, of course, he already has attained, either an increase or has already attained an advanced level of technology, or has attained more resources, then he is able to reach point C, because in this means that he has economic growth, and with economic growth, then the expectation is that the BBF will shift outward. Okay, now we move to problem 2. Problem 2 says the following BBF shows an economy with one individual Rami and his production possibilities of PC, mouse, and keyboards. So we have two goods, keyboards and PC, mouse. As you can see, the production possibility of routine is a straight line, which implies that the opportunity costs are constant. This is what we discussed during the lesson. Now, we have a bunch of questions over here regarding this problem. First question, can Rami produce 18 mouse and 10 keyboards? Would it be possible for Rami to produce levels E of production? Compute the opportunity cost of production of mouse in terms of keyboards for Rami. Calculate the opportunity cost of production of keyboards in terms of mouse for Rami. What would you say about the opportunity cost in this case of BBF? And what levels of production are considered efficient for Rami? Okay, now we move to part 1. Question number 1. Can Rami produce 18 mouse and 10 keyboards? Look over here. This is 18 mouse. M stands for M mouse, and K stands for keyboards. So that's 18 mouse and 10 keyboards. That's 10 keyboards. So we're talking about combination D. We're talking about combination D. Can he produce D? Yes, indeed, he can produce D. Why? Because D is located in the attainable region. It's inside the BBF. So Rami can produce any combination along the BBF and inside the BBF. And since D is inside the BBF, yes, indeed, he can produce D. Now, will it be possible for Rami to produce level E of production? Where is E located? As you can see, E is located beyond the BBF, outside the BBF. Therefore, E is in the unattainable region, which means that he can't produce at E. Therefore, we say it's not possible for Rami to produce at E because E is located beyond the BBF, or it's located in the unattainable region. Now, what about 3? Compute the opportunity cost of production of mouse in terms of keyboards for Rami. So, as you can see, if Rami were to move from A to B, along the BBF, then what happens? Then the production of mouse will increase and the production of keyboards will decrease. The production of mouse will increase from A to B. At A, he is producing 6 mouse. At B, he produces 18 mouse. At A, he produces 6 mouse and 35 keyboards. At B, he produces 18 mouse and 25 keyboards. So, as he moves from A to B, then the production of mouse increases from 6 to 18. That is, the production of mouse, the quantity of mouse increases by 12 units of mouse. How about the production or the quantity of keyboards? The quantity of keyboards will decrease from 35 into 25. Therefore, as he increases the production of mouse by 12 units, then the production of keyboards will decrease by, from 25 to 25 will decrease by 10. So we say the opportunity cost of 12 mouse is equal 10 keyboards. the opportunity cost of 12 mouse equal 10 keyboards. Great. So opportunity cost of one mouse, or what? Because he wants the opportunity cost of one mouse. So what we do, we divide by 12 both sides, divide by 12 here and here. We come up with the opportunity cost of one mouse is equal 5 over 6 keyboards. Okay. Now, part 4, calculate the opportunity cost of production of keyboards in terms of mass. If the opportunity cost of one mouse equals 5 over 6 keyboards, so what is the opportunity cost of one keyboard? So all we have to do is to multiply both sides by 6 over 5. Look, opportunity cost one mouse is equal 5 over 6 keyboards. So if I want to get one keyboard, what I do? I multiply here times 6 over 5, over here 6 over 5. So what we get here? So it means it's 6, 6, 5, 5. So one keyboard equal what? 6 over 5 M. 6 over 5. What is that? Opportunity cost of keyboard and mouse. One keyboard is equal 6 over 5 M, which is equal 1.2 mouse. So the opportunity cost of keyboards in terms of mouse is equal 6 over 5 mouse, which is equal 1.2 M. Great. Now, what would you say about the opportunity cost in this case of BBF? Just simply you say that since the BBF is a straight line, then the opportunity costs, are constant. Okay, the opportunity costs are constant because, the BBF is a straight line. What levels of productions are considered efficient for running? Remember, when you hear or see the word efficient, then look at the combinations that are along the BBF. What are the combinations that are along the BBF? A, B, and C. And those are the most efficient combinations of productions. So here saying what levels of productions are considered efficient for running, we say the combinations of production that are efficient for running are A, B, and C. Why? Because they are located along the BBF. Okay, now we move to problem 3. Problem 3 says Sarah has the following production possibilities of tables and books. So we have two goods, one tables and the other one, of course, books. Now, as you can see, this is the combination of the two goods that Sarah produces 0 tables and 40 books. This means that she has devoted all her resources in the production of books, and no resources, are devoted to the production of tables. At combination B, of course, she is producing 12 tables and 24 books. This means that she has divided her resources between books and tables. Now, at combination C, she is producing the maximum amount of tables and 0 books, which means that she has devoted all her resources to the production of tables. Now we have 4 questions concerning this problem. First, calculate Sarah's opportunity cost of production of tables in terms of books. Of course, if Sarah is to move from combination A to combination B. Of course, as you see, when Sarah moves from A to B, what does she forfeit? In terms of books to get 12 tables. As she moved from A to B, of course, the quantity of tables increases by 12. What about the quantity of books? It decreases from 40 to 24. That is, it decreases by 16, books. So the question is that the opportunity cost of producing 12 new tables is 16 books. The opportunity cost of 12 new tables equals 16 books. So and usually we talk about the opportunity cost of one in terms of one. So what is the opportunity cost of one table in terms of books? So if the opportunity cost of 12 new tables equal 16 books. Now what is the opportunity cost of one table? So what we do, divide both by 12 and we come up with one table equal 3 over 4 books, because 16 over 12 you come up with here there's some mistake, I guess. Of course, the opportunity cost of 12 new tables equals 16 books. So the opportunity cost of one table, we divide both sides by 12, so we come up with 4 over 3 book. Why? Because we divide by 12, so if we divide both sides by 4, we come up 4 over 3. So one table is 4/3 book. So the opportunity cost of one table is going to be equal 4/3 book. Now we move to talk about the opportunity cost of Sarah as she moved from B to C. As she moves from B to C, of course, the quantity of tables increases by 12, from 12 to 24. So it increased by 12 new tables at the expense of what? Of books. Now, how many books, how many books are decreased? Of course, when she moves from B to C, of course, we see that the quantity of books decreases from 24 to 0, which means that the opportunity cost of 12 new books is equal 24, 12 new tables is equal 24 books. So the opportunity cost of 12 new tables, because tables increase from 12 to 24, so we have 12 new tables, are produced at the expense of 24 books that are not produced. So we say that the opportunity cost of 12 tables equal 24 books over here. The opportunity cost of 12 tables equal 24 books. So actually we look for the opportunity cost of one table. So the opportunity cost of one table is going to equal, we divide both sides by 12 and we come up with 2 books. The opportunity cost of one table is equal to books. Okay, now, of course, C3 comment on the opportunity cost evolution. Now, as you can see, the opportunity cost as she moves from A to B and then from B to C is increases from 4/3 to 2. This means that we have an increasing opportunity cost, and this means that when we experience an increase in the opportunity cost, we say this is the characteristics of a concave downward BBF. So actually, we have a concave downward or bowed outward BBF since we have an increase in the opportunity cost. Okay? Well, because we have an increase in the opportunity cost. Now, of course, draw the corresponding BBF, of course, we put these, we have books along the vertical axis, and we have tables along the horizontal axis. And usually, tables is increases, as Sarah produces, and books are decreases. If you move from here, 0 to 12, 12 to books. So we usually put that one along the horizontal axis, the ones that is increasing, of course, and the one that is decreasing, we put it along the vertical axis. So books is along the vertical axis and tables along the horizontal axis. And you can see that we get a concave downward BBF. Okay, this is here, we said concave downward BBF. Okay, now we move to another problem number 4. It talks about specialization and the trade. Of course, below is a table showing different combinations of good X and Y being produced by 2 producers, namely Hassan and Hasna. This is, of course, the BBF of both producers. Hassan, this is the BBF of it, the combination of X and Y that he is producing. And this is the combination of Hasna of the two goods, X and Y, that she is producing. Now, of course, we have some questions concerning this problem. The first question says, what is the opportunity cost of production of 1 unit of X in terms of Y for Hassan? What is the opportunity cost of producing 1 unit of Y in terms of X for Hasna? 3, who has a comparative advantage in the production of X and who has a comparative advantage in the production of Y? 1. 4, who should specialize in the production of X and who should specialize in the production of course, Y. Now, we move to solve question number 1. What is the opportunity cost of producing 1 unit of X in terms of Y for Hassan? For Hassan, of course, as Hassan moves, increases his production of good X from 15 to 30. Okay, he is increasing his production from 15 to 30. What happens to the production of Y? As you know, always we have a kind of a trade-off. More production of X means less production of Y. So production of X increases from 15 to 30. What happens to production of Y? Of course, decreases from 20 to 10. Now we say the opportunity cost of production of good X, okay, as he increases his units of good X from 15 to 30 is what? Is 10 units of Y. In other words, the opportunity cost of 15 X is equal 10 Y because he produced a new additional 15 X at the expense of what? Of 10 Y. That when he produced 15 new X, he lost or he decreased his production of Y by 10, from 20 to 10. Therefore, we say opportunity cost of 15 X is equal to 10Y. What is the opportunity cost of 1X? Usually we talk about the opportunity cost of 1X or 1Y. Okay? So the opportunity cost of 1X, all we have to do, we divide both sides by 15. So we divide by 15, we come up with what? Opportunity cost of 1X equal 10 over 15Y. And then, of course, we divide by 5 both sides. We come up with what? 2/3 Y. Okay? Or opportunity cost of, if the opportunity cost of 1X equal 2/3 Y, what is the opportunity cost of 1Y with respect to Hassan? If 1X, the opportunity cost of 1X equal 2/3 Y, then the opportunity cost of 1Y, all we have to do is just multiply both sides by 3/2. We multiply the 1X by 3/2, we multiply this one by 3/2, okay, and we get 1Y, and equal what? 3 over 2X. So opportunity cost of 1Y is equal 3 over 2X. Okay? We could, play with the opportunity cost, from X to Y. If the opportunity cost of 1X equal that number, then we could calculate the opportunity cost. If the opportunity cost of 1X in terms of Y is equal to a certain number, then we can calculate the opportunity cost of Y, in terms of X, okay, for the same person. This is what we did over here. The same thing is talking about what is the opportunity cost of producing 1 unit of Y in terms of X for Hassan, for Hasna. The same thing, this Hasna over here, as she moved, we need the opportunity cost of what? Of producing 1 unit of Y. So as you see, as the production of Y increased from 40 to 80. What happens to the production of X? Decreased from 20 to 10. So we say opportunity cost of 40Y is equal what? 10X. Opportunity cost of 40Y is equal to 10X. Now we need the opportunity cost of 1Y. So what we do, we divide both sides by 40. 40 here, we come opportunity cost of 1Y is 10 over 40, we come up with 1/4 X. If we calculate the opportunity cost of 1Y, which is equal 1/4 X, we can calculate the opportunity cost of X in terms of Y for the same person. So what we do, multiply both sides by 4, okay? And we come up with opportunity cost of X is equal 4Y. Okay? If 1Y opportunity cost is equal what? 1/4 X. If I want to calculate the opportunity cost of X, opportunity cost of 1X, what do we do? I need 1X. So multiply this and this by 4. If I multiply both sides by 4 here, and this one by 4, so we got what? X is equal what? Cancel out, so you get 1X equal what? 4Y. And this is what I did over here. Okay? This is how you do it mathematically. Okay? Now, question 3 says, who has a comparative advantage in the production of X? Remember, in the explanation of the lesson, we said, a person is said to have a comparative advantage in the production of a certain good if he can produce that good at a lower cost than the other person. So look over here. Hassan produces X, the opportunity cost of X is 2/3 Y. What about the opportunity cost, for Hassan of 1X? Opportunity cost of 1X is equal 4Y. So as you see, when Hassan produces X, he forgo 2/3 Y, less than 1 unit of Y. However, when Hasna produces X, she forgoes 4 units of Y, which means that Hasna has a higher cost of producing X than Hassan. Therefore, Hassan has a comparative advantage in the production of X because he has a lower cost of producing X than Hasna. Great. Now, what about good Y? Who has a comparative advantage in Y? Usually by law, if one of the persons has a comparative advantage in X, then the other person should have a comparative advantage in Y. However, we can verify this. We can verify, if the other person has a comparative advantage in the other good. Now, for Hasna, of course, can reduce Y. If she produces Y, she loses 1/4 X. However, Hassan, if he produces Y, he forgoes or loses 3/2 X, which means that Hasna has a lower cost of producing Y than Hassan, because here, opportunity cost of 1Y for Hasna is 1/4 X. However, here, the opportunity cost of 1Y equal 3/2 X. So we say here that Hasna has a comparative advantage in the production of Y, since she is producing Y at a lower cost than Hassan. Now, we move to problem 4, or question 4. Who should specialize in the production of X? We said that, Hassan, has a comparative advantage, of course, in X. If he has a comparative advantage in X, then the economist says he should specialize in the production of X, because he has a comparative advantage in X, because he is able to produce X at a lower cost. Why should he focus in the production of the other good? He should, focus upon the production of the good that he is able to produce at a lower cost. Therefore, Hassan should specialize in the production of X. And Hasna should specialize in the production of Y because she has a lower cost of producing Y. Therefore, it costs her less to produce Y. Therefore, she should specialize in the production of Y, which means she only produces Y and nothing of X.